Alright, in an effort to speed things along, I've already drawn all the Lewis structures so that I don't have to do that. We have here our carbon atom connected to 4 hydrogens. And you can see that it's very difficult to draw something three-dimensionally. But by drawing the Lewis structure, we can count how many total bonds there are. Now remember that these bonds are overlapping orbitals. They're orbitals coming out from the central atom and then the single orbital from the hydrogen. There's 4 orbitals, one is an s, and then there's 3 p's. So we call this an sp3 structure, sp3 hybridized, because the s orbital and the p orbitals all bonded together. If we count, we have 4 bond areas, no lone pairs. Our geometric shape's name is tetrahedral. And our angle, as opposed to 90 degrees, which is, if we drew it flat, we can actually spread them out a little more. The electrons push each other away, and we get 109.5 degrees. Our second one, ammonia, our model would look like this with that lone pair. We have 3 bond areas and 1 lone pair. That still adds up to 4, which means we're still sp3 orbitals. So we're still 109.5 degrees. But because we're missing 1 atom, we call this a trigonal pyramidal. The base is 3, and it looks like a little pyramid. Water's our next one. Again, you can see we have that same basic shape that we've had with the other 2. So once again, our angle is going to be 109.5. Our hybridization is going to be sp3. And they're actually a little bit less than that, but I'm not going to worry about that. We have 2 bond areas and 2 lone pairs. This is named bent. Alright, our next one, we're going to have 3 bond areas. 1, 2, 3. I just realized I didn't put all the dots on my oxygen. Sorry. Three bond areas and 1 lone pair. So this is the same shape, trigonal pyramidal. The bond angle is still 109.5 degrees. We still have 4 bond areas, so we're sp3. For carbon dioxide, we end up with double bonds. And somehow, my double bonds have disappeared. When we draw this, we would see that we would have 2, 4, 6, 8. We'd have 8 on each oxygen, but not on carbon. In order to get full 8 around carbon, each oxygen shares 2 electrons. And again, I've not drawn enough electrons. Sorry. So we only have 2 bond areas this time. That means we're only going to use an S and a P for our hybridization. We have 2 empty p orbitals that are actually involved in the double bond. This is a linear molecule, and it's 180 degrees. And this is what it would look like. The next one would look like this. Sorry, I thought I was ready, but I wasn't. A carbon in the middle, 2 hydrogens, and double bonded to an oxygen. Okay, we end up with 3 bond areas. No lone pairs. I just started right pair. So again, we are not using all the S and all the P's, we're only using 2 P's. So we say this is sp2. If you look, our bond angle is at 120 degrees. And the shape is still trigonal, but now it's a plane, so it's trigonal planar. This Lewis structure would simply look like this. 2 oxygens, pretend like that guy's an oxygen, and then a lone pair. This shape's still 120 degrees. We only have 2 bonding areas, but we do have 1 lone pair. So we have 3 orbitals involved, sp2. Our bond angle is 120 degrees. This guy is also named bent, like the water molecule. Alright. Nitrate is going to have a double bond in there. This is not showing it, but this is just going to make things a little bit easier. Here's this basic shape. We've got 3 bond areas, no lone pairs. So this guy's name is trigonal planar. 120 sp2. Our next one, you'll notice we've got 5 fluorines. And you may be scratching your head saying, wait a minute, I thought we had the octet rule to fill. But this guy breaks that rule because phosphorus has 10 around him. Well, if you remember when we talked about electrons in our Aufbau hotel, the first level has just an s orbital, the second level has an s orbital, and the p orbitals. And then the third level has the s orbital for phosphorus, and he has p orbitals. And he has empty d orbitals that don't actually fill till 4s has filled. But those empty d orbitals are there. So phosphorus actually will take this electron out of the s orbital, because remember, half filled is better than nothing, and move him out here, and that gives him 5 orbitals to bond with. So this is now sp3d. Our shape, let's see if I can hold it up far enough out you can see it. We've got kind of a central long one, and then those 120 degrees around the edges. Okay, so if you want to build this, get the tan one out and put 5 hydrogens on it, or 5 white ones on it. Okay, this has 5 bonds. And the name of this, there's 2 pyramids, and they're still 3-sided, so we're trigonal bipyramidal. And we have 120 degrees around the center, but then these are all 90 degrees from either the top or the bottom. So we also have 90-degree angles. The next one, sulfur tetrafluoride, 6 plus 28 adds up to 34. If we put electrons around our 4 fluorines, that adds up to 32. We're going to have 2 additional electrons for a lone pair. So here we have 4 bonds and 1 lone pair. Our shape, therefore, we lose one of the middle guys. We make a seesaw. Oh no, where's my movie? Alright. This is our shape, and the shape's name is seesaw. And if you think about it, that's because if you turn it like this so that it's on its lone pair, you can twist it back and forth like a teeter-totter or a seesaw. Or you can set the two middle 120-degree angle and it teeter-totters back and forth, whichever way you see it better. So this shape is the seesaw. Our bond angle, we have 120 degrees, and then we have 90 degrees. And our hybridization is sp3d. For the next one, we have enough electrons. We have 28. We would use 24, putting 3 fluorines on. 25, 26, 27, 28. So we have 2 lone pairs and 3 bonds. So we're going to remove another and put an orbital, and we get a T shape. Now our angles are all 90 degrees. Still sp3d. And then the last one on the page, we're going to have 3 lone pairs. So we end up with just a guy on top and a guy on the bottom. 2 bonds. 3 lone pairs. Our shape is linear, and we have a 180-degree angle. Our last page, you're going to need to use the silver middle and put 6 bonded atoms on. Once again, we have an expanded valence. Sulfur is in that 3rd energy level, so he has d orbitals to work with. So we have 6 orbitals in total bonding. So that's sp3 is 4, and then 2 d's, sp3d2. Our shape here, we've got bipyramidal again. We have a pyramid on top and pyramid on the bottom, but these are square instead of triangular. So these are square bipyramidal or octahedral. Will work as well. And all of our bond angles are 90 degrees. That's pretty easy to see. Our next one, we have 5 fluorines, but we have enough electrons to have a lone pair. This makes our square pyramidal. We have a pyramid shape that's square on the bottom. So if we count bonding areas, including the lone pair, 1, 2, 3, 4, 5, 6 bonding. Well, 5 bonds, sorry, and 1 lone pair for a total of 6. All 90-degree angles, sp3d2. Our last one, we've got a flat square, 4 bonds, 2 lone pairs. This is just a square planar. (90°), sp3, d2. All right, thank you very much.